All right, lesson 8.4 is adding and subtracting rational expressions. Now, before we get started on this, I wanted to cover a few basic review problems that didn't involve any x's or y's. But remember, when you add or subtract a rational or just add or subtract fractions, you need to make sure and have common denominators. Now, remember, when you're talking fractions, the denominator's on the bottom. Easy way to remember that is either Notre Dame or you can remember North Dakota. And remember, the denominator is on the bottom. So the bottom number is the one that we're looking to get the same, okay? And then all you're going to do is you keep the denominator the same. It doesn't change. And you're only going to add or subtract the top number, okay? All right, so let's take a look at just some basic fractions before we get started on this. So we wanted to, number one, we want to add 2/3 plus 4/3. And then when we're looking at this, when you add the denominator, so the number on the bottom is already a 3. So all I'm going to do is I'm going to take 2 plus 4, and they go under that common denominator. Well, 2 plus 4 is 6 over 3. And then you should always reduce your fractions. And 6 over 3 will reduce to 2 over 1, which goes to finally to 2. Okay? Now, number 2, if you'll notice, I have 1/2 plus 2/3. Well, those are not common denominators. So the first thing I need to do is I need to find what number that 2 and 3 both have in common. So the multiples of 2 are 2, 4, 6, 8, 10, and so on. Okay, we can add more if we need it. The multiples of 3 are going to be 3, 6, 9, 12, and 15. And then, again, we can add more if we need it. And you find that the first number that these two have in common is 6. So that's what we're actually going to change the denominators to. We're going to change them both to 6. So what you need to ask yourself is 2 times what will give you 6? So you multiply it by 3, and you've got to do the top number. 1 times 3, which gives you 3. 3 times what will give you 6? So you multiply it times 2, multiply the top one by 2, and you get 4. And then just like the previous one, 3 plus 4 gives you 7 over 6, and it can't be simplified. On example number 3, when you're subtracting 3x plus 6 minus the quantity x minus 2, remember when you're subtracting polynomials, this one gets changed to a plus, and you change the sign of both of these. So 3x minus x gives you 2x, 6, and a positive 2 gives you plus 8. Okay? All right, so let's take a look at some rational expressions where it may not actually end up like a fraction like you're normally looking at, but we got 4 over 3x plus 5 over 3x. So the rules of this thing actually remain the same, and those don't change. In other words, the denominator, when you're adding the fractions, has to be the same. You have to have common denominators. So 3x and 3x are both the same. So all I'm going to do is take 4 plus 5 over that common denominator. Well, I can't add 4 plus 5 because they are like terms. So 9 over 3x, which can eventually reduce to 3 over x. Okay? 9 divided by 3 is 3. 3 divided by 3 cancels to 1. Okay? All right, number 2. Same thing. If you look at this, my denominator, I have 2x over x plus 3 minus 4 over x plus 3. And my denominators are both x plus 3. So the only difference is, since this is a minus, remember we're going to change that to a plus and change everything that comes after that to its opposite. So on the top, I end up with 2x minus 4 over x plus 3. And it can't be simplified any further. 2x minus 4 cannot be combined. Okay. So go ahead and try the next two examples, examples 3 and example 4. So go ahead and pause the video. All right, let's go ahead and complete these. So on example 3, since the denominators are already the same, I can simply take, and you should get in the habit of changing your signs, 3 minus 7 over that common 2x. Well, 3 minus 7 gives me a negative 4 over 2x. Negative 4 and 2, that gives me a negative 4 divided by 2 is negative 2. 2 divided by 2 goes to 1, so I just put my x. So 2 over x. On example 4, your denominators are already the same, so it's going to stay x minus 4. And on the top, I have 3x plus 6. Okay? And I can't simplify it any further, so I am finished. All right, so let's go ahead and jump over to example number 5. Actually, example number 6, I think we reordered these. If you'll notice, when you're looking at your denominators, which is the bottom fraction, I have x plus 2 plus x over x minus 1. And as it right now, my denominators are not the same. And since they both have a plus sign in them, these two need to remain together. Okay? So what we're actually going to do is we need to look at these. And so the one on the left has an x plus 2. So when we're adding these, they both exactly have to be the same. So we're just going to add an x plus 2 over here. Okay? And on the top, if we add it, remember when we add it to the top, or to the bottom, we've got to add it to the top. Because x plus 2 over x plus 2 is a form of 1, and we're not changing the value of it. Okay? Over here, I have x minus 1 that I need, so I got to add it to the top. Okay? So now I have an x minus 1 on both of them, and I have an x plus 2 on both of them. Okay? So the bottom part of this fraction isn't going to change. X minus 1 times x plus 2. Okay? It stays as it is. On top, I need to distribute these so I can combine my like terms. So I get 5x minus 5. Since it's a plus, I don't have to worry about changing any signs. So x times x gives me x squared. And 2 times x gives me 2x. Okay? Remember, we need to write stuff in descending order. The bottom of the fraction doesn't change. So I have x squared. I can combine 5x and 2x to give me 7x minus 5. Okay? And you are actually finished then. Okay? All right, so let's take a look at example number 5. Again, we don't have like denominators. And I have x squared plus 6 plus 9. And on the bottom, I have x squared minus 9. Now, since I'm actually, this is a subtraction problem, first thing I'm going to do is I'm going to change those signs. Now, you would probably want to be in the habit of saying, hey, I can actually go ahead and simplify that plus 1 and negative 1. But remember, we can't do that because we don't have common denominators. And when you've actually got polynomials on both sides of this, the first thing that you're going to need to do is you need to make sure that everything is factored as far as you can factor it. So what will add together to get me 9? So I can do 3 times 3. Oh, wait. Yeah, that adds together to give me 6. So I'm going to turn this to x plus 3 times x plus 3. Okay? Remember, this is a perfect square. This is a perfect square. So it's just x plus 3, x minus 3. Okay? So then the very first thing I need to look at is this one has 2 x plus 3's in it. Okay? So I've got to add another x plus 3 over here. And if I add the x plus 3 to the bottom, I got to add it to the top. Okay? So then I look over here and say, okay, I've got 2 x plus 3's. I'm missing an x minus 3. So I need to add the x minus 3. All we're doing is adding on both sides whatever we don't have. So when we're finished, we're going to have both sides look exactly the same. So we should have 2 x plus 3's and an x minus 3. Okay? So then on top, now that our denominators are the same, we can distribute those. So x times x is x squared. X times 1 gives you x. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. Here, distribute, make sure you distribute the negative 1, so it's negative x minus 3. And the last and final step, your bottom needs to stay on there because it is a fraction. And on the top, we need to combine all of our like terms. So x squared, x, negative 3x gives me negative 2x. because these three can all be combined. So x, negative 3x gives me negative 2x. Another x gives me a negative 3x. And then this negative 3 and negative 3 will give me a negative 6. And you are finished. Okay. Okay. So that concludes lesson 8.4. So go ahead and do some of the practice problems before moving on to the second video or any of the quick checks. And make sure that you're actually getting the same answers and then submit it. So, okay.